All right, so as you can see, we're in Chapter 8. We're talking about right triangles and triangle measures. The big thing today, our goals, kind of talk about radicals and roots, but we're not going to spend as much time as we did yesterday. We spent the entire class yesterday talking about radicals and roots. The big thing today is to talk about these theorems. I want to do a quick review of Theorem 8.1. Let's review that. If you don't know 8.1, we won't be able to do the rest of these theorems. The new ones today, we got to talk about these two. Okay, these two are basically, I don't want you to memorize the two theorems, 8.2 and 8.3. I want you to know the formula that I'm giving you with these. Like, how do you set it up? That's what we need to do today. So I'm going to go through those pretty quick. We're going to try to do at least an example of two of those, where you can see numbers on a triangle and how you can use it. Okay, these two theorems are used to find walls of a triangle, a right triangle specifically. So that's what we're going to be getting. So hopefully that'll make sense. Now, obviously, with these, we need to know the definition of what a geometric mean is. We talked about this, I think, on Wednesday this week or Tuesday. We talked about mean versus extreme. We're going to talk about those two. We are getting new homework today. It'll be due, I believe, Wednesday next week. The good part is it's just based on simple calculations, just algebra. There's no proofs or anything like that. It should be very, very straightforward and very easy, as long as you pay attention today. Make sense? All right, let's jump right into it. The first one here, radicals and roots. Remember, when you have a radical today, you need to break down this number right here, the radicand number. That's the number you're breaking down. So if you're doing this problem, because I haven't actually talked about this problem yet, I've shown it on the board like 3 days in a row. When you break this down, remember, the index number is a 3. So when you break down the 8, you want to try to break this down to numbers that multiply to give you 8. So like 4 times 2. And again, you leave the cube root outside, the cube, the power of 3. Then you break down the 4 even further, and don't lose track of all these numbers. So now there's 3 numbers inside that radical. It's 2 times 2 times 2. And then what you do is, when you look at the index number is a 3. Right? That's your index number. So that means you're trying to find a triplet. Well, we do have a triplet here. We do have a triple of numbers. If there is no triplet, you don't have to circle anything. You don't have to throw things outside the parenthesis. Your answer would just be the number you started with, because you just leave it alone. But I do have a triplet. So the rule was you cross 2 of them out and you kick 1 out. You cross them all out and you kick 1 out. So there is a 2 on the outside, a big 2. Now, inside the radical, inside this cube root, what is left over? Nothing. Yeah, absolutely right. There is nothing left in here. You don't put a 0, don't put a 1. No number is left on the inside. So the radical goes away. So your answer for this problem is just 2. That's the cube root of 8. Okay, that's what we talked about yesterday. That works for any type of radical, including square roots and quartic roots and other things, where you look for whatever the index number is on the outside. You look for triplets or doubles or quadruples, right? And you're trying to circle them and kick 1 out, okay? If there's any numbers left on the inside, you leave them there. And remember, you don't suddenly change the operation. You stay with addition or you don't change it to addition or subtraction or division. It's only multiplying on these problems. Does that make sense? We're going to do at least an example of this today, why you'd actually need to know radicals, because I want to get to that, okay? All right, let's jump to the next slide. The Theorem 8.1, this talks about when you draw this line going straight down, this line in the right triangle. And again, the right triangle, this was the right angle of the original triangle. And again, it's the big triangle here. That's the one I'm looking at. When you drop that altitude going straight down in that triangle, it's breaking these up into 2 triangles. This tiny one, which is this one, and this really small one, which is this little guy. Those are the resulting triangles. What this theorem says is that all 3 triangles, the big one and the 2 remaining small ones, are related to each other. Does that make sense what this one's saying? And again, the reason why we talked about this on Wednesday was because they share 2 angles. If triangles share 2 angles, they're automatically related to each other. There's a scale. If you have an iPhone, you can pinch and zoom, and you can rotate them, and they would be the exact same sizes eventually. Okay, so they are related to each other. Now, let's get to our new properties today. We have 8.2. This is one you want to write down. Now, if you can't see the board, apologies, move closer. I'm totally fine with that. So we have an altitude drawn towards the hypotenuse. And again, on this original right triangle, and I'm going to draw on this for a little bit here. Let me change the color here. This side right here, that's the hypotenuse. That's the hypotenuse. Okay, it's the big wall. Because, again, the right angle is on the top of the big triangle here. So we do have a hypotenuse. What this one is saying is that when you drop that altitude straight down, which, if I get rid of all these letters here, this is the altitude. That's the line you're dropping straight down. That line is related to these two. So the line going straight down, and again, if you need to rotate your picture in your book, you can do that. You have the luxury of like turning the pages and stuff. That wall is related to the other two. Now, if you read the actual theorem here, it's saying that that altitude is considered the geometric mean between the two parts of your hypotenuse, the two segments of the hypotenuse. Okay, what it means to be a geometric mean, it means that that wall, the H wall, going straight down, is set up in a formula. I'm going to write down the formula right now so you can see this. I'm going to put it down below so you can hopefully read this. So what it's actually telling you is that when you set up this formula, which I know is going to seem a little odd, this is the proportion you can set up. That the two parts of the hypotenuse are here and here, diagonal from each other. Those are where the two parts of the hypotenuse would go, and then the height going down would be these two. It'd be the same number in both spots. So let me get rid of those arrows. Okay, does everyone have the formula written down? Okay, so x over h, h over y. Now, when I look at a triangle, this is what I see, and I'm going to circle this just so you can see this. So if you have a right triangle and you have that altitude going down, these are the three numbers I look at. Does that make sense now? Those three are in relationship to each other. Now, the reason why is that these triangles are proportional, so we can actually set up this. Now, I will talk about this more maybe Monday because I'll give you time to work on this. But what I want you to get from this is that these three parts are related to each other. There's a perfect proportion between them because right triangles are set. They're set numbers and scales from each other. Okay. Now, I'm not saying that these walls are equal. They're proportional to each other. There's a scale. I know some of you are still writing. The goal today is my next slide will have this big picture up here. I'm going to fill in a couple numbers, and we're going to try two problems with this so you can see this. Now, again, this is the problem that you might need a calculator on today. So now if you want to borrow one later, maybe you want to go grab one, that's fine. You can do that, but make sure you get it back because all my classes will need them. And this is, so I'm going to do two of these so you can see how this works. Okay, is everyone good? Everyone has the formula? Okay, let's move on. Okay, let's use this. So let me give you another picture here. So here's my big picture I just showed you a little bit ago, but I'm going to throw some numbers in here. So let's say we knew the height. So let's say the height of this triangle, let's say it's 6 inches. 6 inches, okay? And let's say that we knew x, let's say x is 4 inches. And I want to know this part right here, that letter y. So these are the three parts of the right triangle that I have, and I want the y. Okay, so we can set up my formula. So again, let me set this up. Let's go with a bright color. Let's go green here. Okay, so how we're going to set this up? We're going to go the x over the height, so that's 4 over 6 equals. And we're going to go the 6 over y. Because again, it's the small part over the height going down, and then it's the height going down over the other piece, the y. Now again, if you want to see the relationship here, I'm going to make a little mark here. These two parts right here, are the parts of the hypotenuse, the bottom. The one going this way should be the same number. That's the height. That's how I think of it. So I'll write the formula down here in a second. Now, to solve this, again, what we talked about last time was you start with the number above or below the y. So wherever the y is at, you start with the number above or below it. So in this case, we're starting with the 6. You're going to cross multiply and divide, and it looks like a goldfish. Yes, I'm going to draw a little goldfish here. So here's my little beta fish. Okay? I know that seems stupid, but you remember it. So we're going to be taking 6 times 6, dividing by 4, and that gives me the length of y. Now, 6 times 6 is 36. We're going to divide by 4. And what's the length for y? 9. And that would be in terms of inches, because that's the labels on all my others. That's how you find it. Now, again, I'm going to write down the formula here just so you have it. Again, it is the part of the hypotenuse over the altitude, the line going straight down, and that's equal to the altitude over the other part of the hypotenuse. And again, the parts of the hypotenuse are x and y. The altitude is the line going straight down. That's the generic formula that I'm using. All right, any questions with any of the math that I've just done here? I think it's pretty easy. Once you see it set up and you watch somebody do it in front of you, it's not really that difficult. Now, let's do another one. So I'm going to erase all these parts. I'm going to leave that formula up there, but let's do another one. So you're probably thinking, okay, Ward, this is pretty easy. You know, this is something that you could probably done in junior high. Why did we do a day worth of notes on radicals, like square roots? Okay, let me explain. Let me do an example here. All right. Now, can everyone see this? Is everyone being able to see the colors and stuff? Okay, because I know we have a couple of people that are colorblind, so I'm hoping that this is showing up for them. So let's say that we're missing the height. We're missing this number. We don't have the height, but we have the two parts of the bottom. So I'll let you guys make up numbers. I need two numbers for x and y. Any numbers you want.
3.
8 and 3. Okay, let's do that. I like it. 3 and 8. Okay, those are the numbers I heard. And we can give them any length. Let's call them feet. So that's my label, so we're going to call it feet. We can call it yards, meters, whatever you want. Okay, so we have 8 feet and 3 feet. I want to set up the formula how this works. So again, you take the two parts of the bottom, you put them on the diagonal. So I'm going to use the 3 and the 8. Those go diagonal from each other because those are the parts of the hypotenuse. And the one thing I'm missing is I'm missing the height, the altitude. You see how easy it is to set this up? Now, this is the part where you're going to get a weird radical. Because when you actually solve, do you notice I have two variables here? Not just one. So when you try to do that whole fish method, you know, the cross product, that's what they call it, you can't start with the number above or below the variable. I have two variables. So this is where you truly have to know what a cross product means. So actually doing the math here, you have to multiply diagonally. I have to multiply these two things together, so that's h times h. And set that equal to the other two numbers multiplied together. That would be the 3 times 8. 3 times 8. So if you actually do the math here, let's see if I can switch to pink. That's h squared equals 24. Make sense? And now this is why you get a radical, why you get a square root. Because how do I get rid of that power of 2 off the h? You move it over. And what is the inverse operation of a square? A square root. So you have h equals the square root of 24. Now, does 24 have a perfect radical? No, right? Because if you think about the perfect squares, 25 is a perfect square. 5 times 5 gives me 25. So this answer for the square root of 24 is just below the number 5. It's like 4 point something on a calculator. It's not perfectly 4, because 4 times 4 is 16. But it's not 5 times 5, because that would give me 25. So we would have to break this down, and this is the stuff we did yesterday. So if we're breaking down, 24, that's 3 times 8. Those are the numbers I used earlier. We would break up 8 even further to be 2 times 4, and you'd break down 4 to be 2 times 2. So these are all the numbers I would use. And then we would look for a pair, because my index number, now let me write this bigger. So right now we're at this. Whoop. My index number is 2. I have 3, a 2, 2, and a 2. That's like this. That's breaking it down. Do I have a pair on the inside? Because, again, my index number is a 2. So I'm looking for pairs. Do I have a pair on the inside? Yeah, I have at least one pair. There's at least a pair of 2s. So you'd cross one out, kick one out. So the 2 would sit on the outside, and in the inside, I still have the 3 times 2, and that would make 6. So this is my answer. Now that big 2 on the outside, that's not an index number. That's a huge 2 out front. There is an index number of 2, but it's small and you don't have to write it when it's a square root. So this is the answer I'm looking for. That's the height. Whatever that decimal is, it's 4 point something. That's how tall this triangle is. Okay, questions on the math I've just shown you?
So if this was like a math problem, would you write down what we did, the 2 index number, and a 6, or would you write down what the calculator says?
I would write this down. I would write this 2 root 6. I don't want a calculator to be used on that. Now, if you need a calculator to break down 24, or if it's like, let's say it's a larger number, because you will have some big numbers there. Yeah, I can understand why you need a calculator. Like, let's say you didn't know what 308 is, and you're like, okay, how do I even break that down? That's where you'd probably need a calculator. Divide it by 2 and separate them and all that good stuff. So that's something I want you to know how to do. Okay, do we feel comfortable with the first formula? I think it's straightforward. I think it's pretty easy. Now let's go to the second one. Okay, next one. I'll let you have a little bit of time to write this down. It says the altitude is drawn towards the hypotenuse, so it's the same picture I did earlier, but now, as you can tell, I have different labels on the picture. Now, instead of you just using the height going down and the x and y that was on the bottom, now they're labeling everything on this right triangle. They have now labeled the legs. These are the legs of the original right triangle, because they're the parts that touch the right angle at the top. They didn't even label the height, the altitude drawing straight down, but they have the hypotenuse labeled now. They've labeled it with a letter C. So these are the parts that are going to be important. So again, if you're writing this down, I even included the page numbers here because I know we're not in chapter 4, right? I skipped to chapter 8 because there's a couple parts we needed to mix in here. So this one talks about that the hypotenuse and the parts of it are related to the legs now. So they're related to A and B somehow. So you drew the altitude straight down towards the hypotenuse. It separated the hypotenuse into 2 parts. And it's talking about the length of the leg. Now there's 2 legs there, but you're going to pick one of them. The length of the leg is the geometric mean between the length of the hypotenuse and the part of the hypotenuse that is next to the leg. I know that seems really complicated. I'll explain. I'll show you the formula here in a second. It'll make a ton of sense once you see it. But again, the reason why this works is because these triangles are similar to each other. They're related. They're proportional to each other. Okay, let me write down the formula so you can see it. Now, I know a lot of you are still writing the words down because you're trying to get it figured out. Let me give you the formula here, what I'm talking about. So I'll give you guys the option. You guys can pick one of the legs. Now, let me highlight the legs. These are the 2 legs of the original right triangle, the big legs. I would like one of you to pick one of them right now, A or B?
B.
B. I heard B first. That was, sorry, quick on the draw. So we have B. That's the one you guys picked. Okay, we're using B. So what they're saying is that when I set up my little proportion, B is the geometric mean. The B will go here and here. That's the geometric mean. If you look back to the notes we did Wednesday this week, the geometric mean is the diagonal. So the B and B will be there. That's the leg you guys chose. Now if you picked A, you'd put A there. Now, what this theorem is saying is that the other 2 parts, because it's a proportion, right? There has to be 4 terms written in this because it's 2 ratios, 2 fractions set equal to each other. What this one is saying, if you read the words, you have to pick the part of the hypotenuse that's closest to the leg. So which letter on the bottom, X or Y, is closest to the letter B? X. Okay, so let me get rid of that one. X is closest to B. And what is the whole hypotenuse called? What letter did they use? C. That goes right here. That's the formula. That you're going to pick the part closest to the letter B, which in our case is X, and the entire hypotenuse, that goes in the other part. So it's the second formula out of the two. Now, I do want to give you the other formula, because I know some people blurt out that they want to use the letter A. So let me give you the letter A formula. Okay, so if you pick the letter A, let's say you pick this one. Okay, you picked A. That's the geometric mean. So if I have my two fractions, I'd put A and A here and here. Okay? Sorry, that's an A. It's really bad, sorry. That is an A. All right, so you pick A and A. Now, what is the wall closest to A? Y. Okay, you'd put Y here. Apologies. Save 7 cents on gas today. All right. I have Y. That's the part closest. And what's the entire hypotenuse called? C. C is the entire hypotenuse. So that's your formula. Those are your two. You can use either one you want. But they can help us find the lengths of the walls. So if you use both formulas I'm giving you here in tandem, like these two and the other one we just went over a little bit ago, you can actually find all the walls of a right triangle by just giving a select few, which is kind of awesome, like that you can actually do that. Okay, let's do an example here. Anyone still need the formulas and whatnot? Some people are still writing. Okay, Adam, see you later. Okay, did you get your the homework right now? Perfect, thank you. Okay, let's jump in. Let me give you the example here. Hopefully you have these formulas. If you don't, I'll write them down here in a minute anyway. But here's the picture I just gave you a little bit ago. But let's throw some numbers in here. So let's say we're going for the hypotenuse. Let's say I didn't know what the entire hypotenuse was. So this is going to be the thing I want to find here. But we have an X or a Y. So let's say that we have X. Somebody give me a number for X. 21. Okay. So we have 21. Let's say that's in inches. Okay. And now I do need the wall closest to the 21. So I do need the B wall. And now this has to be longer than 21. I'll explain that. 36. I like it. 36. Okay. Now I will need somebody with a calculator here in a minute because I can't multiply those in my head. I can attempt to. All right. So if these are my labels. So the 21 inches and the 36. I can set up my formula because the leg of the right triangle, which is the 36, would go here and here. These are the 36s. All right, that's your leg of your right triangle. You have to use the wall that's closest to the leg. That would be the 21. That would be the part closest to the leg. Because again, these are the legs of the right triangle, so that's how I know. So we use the 36, so that would go diagonal. The 21 is the part closest to it, and the one thing I'm trying to find is the hypotenuse, the entire bottom. And so I can solve for C. Okay, so to solve this, you would start with a number above or below C, and this is the part I said earlier that I was probably going to need a calculator for. Let me switch colors. So I'm going to start with the number above the letter C. I'm going to cross multiply and then divide. And yes, it does make a little pretty goldfish. Here's my goldfish. Okay, so 36 times 36, and we're going to divide by 21. Now, I know this will be a decimal. It's totally fine. I want to know what it is. What is it?
61.71.
61.71. And that's in terms of inches. I believe we use inches as my label. Now, good?
Yeah.
All right. So, now, here's the thing. Why this number makes sense to me. Okay, so it was 36 times 36. That's a really big number. You divide by 21. We brought it down to 61. Why does the number make sense? It's a 2-digit number, like the others, but that's the length of C. C is the hypotenuse. It's this length. Yeah, it was going to be pretty long. Just saying. It was going to be pretty big. Now, it's a decimal. I knew it was going to be because I know 36 times 36 divided by 21 wasn't going to work out pretty. How I know that is 21 has a 7 in it. 36s don't. So dividing by 21 was not going to be pretty. The other thing, it's the biggest wall of the right triangle. so it had to be bigger than the 36. So it was going to be pretty large. Now, knowing the 61.71, I can actually find y. Because these two parts combined, like 21 plus y, has to make the 61, has to make the entire bottom. It makes the whole bottom. So if you add the two 6 together, you can find y. So if you just do a little subtraction, so Taylor, if you still have that calculator up, if you want to just subtract 21 from 61.71, you should get, and if you type it in, exactly, 41.71. Actually, 40.71, thank you, sorry. It should be 40.71. That's the length of y. Do you see how like they all connect to each other? Like it's pretty straightforward. And now here's the coolest part. Now that I know the 40, I can go after A. Because A, I can do the same exact setup. Because A is a leg, I can do the same formula I just showed you here a little bit ago, but now I can find A. Because I have all the parts I need. In fact, let me do some erasing here. We're going to set up A. All right. And let me label my picture. This is the 61.71 inches. All right. Okay, so let's do a little bit of math here. So to find A, this is my leg. That's my leg. That leg of the original triangle would go here and here. That'd be A and A. Terrible A, sorry. I can't do A's today. No good at that. This would be A and A. Then the part closest to A is the 40.71, and the whole bottom is the 61.71. That's the whole hypotenuse. Because again, the leg is in the diagonal, and so we'd repeat A and A twice. You'd have the part closest to A, and then the whole bottom. And that's why this would actually give you a radical. You would actually get a square root on this problem, because when you multiply diagonally, there we go. If you multiply diagonally, I'm going to have to multiply A times A, which is A squared. And now, this is the part I need somebody with a calculator. Question?
So what is the definition of a hypotenuse again?
Hypotenuse is the longest side of a right triangle. It's the side opposite the right angle in the big triangle.
What do you want to put in at work?
I would like you to type in 61.71 times 40.71.
It's 2,512.
2,512.21. Okay, so we got a weird, crazy decimal. And then this is the part where I say you needed a calculator because we have a decimal and we're trying to take the square root of it. This is a part where I would not expect people to break that thing down. Where you're trying to break it up into pieces and try to figure out pairs. It's a decimal. You can't do that as of right now. So you're just going to take the square root of 2,512.21, if that's the correct number. Hopefully I didn't hear you wrong. Now, somebody with a calculator, if you type that in, again, how you get the square, there's a square root key on every calculator. You just have to find it. It's usually you have to hit like the little second key, hit the square root button, and then type in 2512.21.
50.12.
Say it again?
50.12.
50.12. Is that what we're getting? About 2 decimal places, and that's in terms of inches. And that makes sense. This wall was a leg. It had to be smaller than the hypotenuse. Did anyone not figure out how to type it in their calculator? Again, the square root key. Now, I know that some people have like a menu-driven calculator, which is a menu-driven calculator. You can type it in exactly how you see it on the board. You can see it, and then you hit enter, and it gives you your answer. Some people don't have the luxury of that. When you type in your numbers and you hit like a square root key, it flashes on the screen automatically and just gives you your answer. You don't have to hit equals, the equal sign. On those problems, you have to type in the number first, the 2512, and then hit the square root button. Because some people it calculates it automatically when you hit the square root key. So if it's flashing, make sure you're typing that in before you do that. Okay? All right. Hopefully that made sense to you. That you can set your numbers up. It's the leg diagonal, and it's the part closest to the leg and the hypotenuse. One of the numbers will be missing, and you can go find the others. This is the one I said you'll need calculators on. Okay. Now, let's talk about the geometric mean. This is the part I was just showing you a little bit ago. The geometric mean is the number that is here and here. That's the geometric mean. It's the diagonal. That's why on that last problem we were putting the leg there and there, where the x's are. So like in the last formula, I was putting the leg here and here of that triangle. Then I was putting the part of the hypotenuse that was closest to it and the entire hypotenuse right here. because these are the geometric means. So if you look back at the theorems I just wrote, it said we were talking about the geometric mean is the leg, or the geometric mean is the altitude. So you have to go back to those other formulas. Okay? And so why you'd get radicals here from those examples is because maybe you're missing the leg. Like that's your variable. So that's where you have to use radicals. If you're missing one of the other parts, like either the hypotenuse or the part closest to the hypotenuse, then you won't have a radical because one of those numbers will be given towards you, or to you, I should say.
So theorem 8.2 is used for when you don't have a leg, and theorem 8.3 is when you do have a leg?
Yeah, exactly. Yep. Yeah, so if you look back and you look at the formulas, it's like 8.2 is used like what 8.2 is used when you don't have legs, or you're using like the altitude and you're using parts of the hypotenuse. This last one, the 8.3, was used when you're trying to find the legs, or you're using a leg. Okay, here's your homework today. This is what I'd like you to write down. This stuff is due Wednesday, February 7th. That's this coming Wednesday. It's pretty easy. You need a calculator. You will have to do calculations. There is no proofs. There's nothing. You have to calculate things. Now, there is a problem I'd like to go back to. I'm letting you write this down because I want to have you write this down before the end of class here. But I'm going to go back and I'm going to talk about some of these problems just real quick. Because I'm not going to talk about the ones with the formulas. I think those are pretty straightforward. They give you pictures. But there's one problem in particular I want you to look at first. Okay, and the example I'm going to give you is actually probably one of your homework problems. So I'm gonna write this on my little slide. So I'm gonna go back a slide here in a second. Okay, so this is due next Wednesday. 1 through 3, 5, 6, 8 through 10, 18 through 20. They're all calculations you need a calculator. Now, does everyone have this written down? It's on the board up here too. Okay, let me go back one slide. Okay, now I'm gonna erase all the stuff I have written. Okay, I'm going to do an example, and this is actually one of the homework problems, so I'm giving you a freebie right now. Okay, one of the problems says it wants you to find the geometric mean for the following two numbers. It says 5 and 20. That's all it says for this problem. This is, by the way, this is problem number 1 out of your textbook. So it says find the geometric mean between 5 and 20. How you do this? This is what they want you to set up. The geometric mean are these two. It wants you to find x. So you're taking the 5 and 20, putting it in the two diagonal spots, and you're finding the x. You don't have to draw the triangle or anything like that. The geometric mean is those two numbers. The geometric mean is kind of like an algebraic mean. It's a number in between them. So my answer will be roughly somewhere between 5 and 20. Not perfect middle. Don't add them together and divide by 2. You know, it's not going to be 12.5. Okay, that's what you get if you would add them together. I'm talking about the geometric mean is on the picture. So if you drew a triangle, it'd be the wall in between them. Okay, so how this works, you cross multiply. So x times x is x squared. You take 5 times 20. Now, if you don't know what 5 times 20 is, that's a perfect 100. Now, how do you solve that?
Bring it down.
Yeah. You take the power 2 over, you bring it down, right? You take the power 2 over, and you do a square root. Now, 100 has a perfect square root. It's 10, 10. Yep, it's 10. 10 times 10. That's the answer that they're looking for. That's the geometric mean. That's the answer for problem number 1. Now, again, if you don't know how that works, let's say you didn't know, like, oh gosh, I don't know what the square root of 100 is. You could break down 100 into parts and do all the stuff we talked about the other day. That, you know, maybe 100 is, maybe you thought it was 4 times 25, or maybe it was the 5 times 20, or maybe you knew it was 10 times 10. And you're breaking these up further and further and further. So 4 is 2 times 2, 25 is 5 times 5, and eventually, you know, you get something like this. Since it's a square root, it has an index number of little 2 outside. They don't print that. You'd circle pairs, you'd cross one out, and kick one out. So the 2 and 5 are on the outside, and there's nothing left in the radical. So that's why the radical goes away, and your answer is just 2 times 5. Question?
So if your square root is a decimal, do you keep breaking it down, or?
Yeah, I want you to break it down. On these problems, like these where they ask you to find geometric mean, you do not need to type it in your calculator. You do not need to type it in the calculator. I don't want the decimal of it. I want this answer. I want this or the simplified version of the radical, like we were doing earlier. So maybe you can multiply the two numbers together and it gives you 24. Break it down. Break down 24 and give me what the radical is in the end. That's why we practiced that all day yesterday. Okay, that's it for today. So remember, let me go back to the last slide. This is the homework that's due Wednesday. Okay, I gave you number 1, and that's a lot of them. So it's a lot of just breaking down radicals. Okay, good luck. I will be back Monday, and we'll talk about this, and we'll do a couple examples, and I'll give you plenty of time on Monday and Tuesday to work on this. Okay.